going to show you one more kind of plot. It's a box plot. And the first way of displaying it is quite easy, actually. Box plot is another function besides just plot. And it can take a formula like the regression model. Although I think it's pretty much only useful when you only have one predictor variable or independent variable, and that variable is categorical. So here's dat. There's also this column called race, which has 3 unique values in this data set: Asian, Black, and white. And so those can be treated as categories. And I can calculate statistics about the scores for each of those 3 groups. And by calling box plot with this formula, where age is on the y-axis and race is on the x-axis implicitly, because it comes after the tilde, and the data comes from this data set called dat, then it knows to calculate the statistics that I'm asking for separately for each of these 3 race categories. Does anyone remember what a box plot is from maybe intro to stats, or maybe from like high school? What do all these lines represent in a box plot? Yeah, they're quartiles of the data. So a quartile is a point in the distribution of data such that a certain percentage of points fall below that threshold. The thick, bold line in the middle is the median. That's the point where 50% of the data is below that line. Also, so the median is also known as the 50th percentile. So for the Asian participants in this data set, 50% of them are below like 32 or whatever. On age, I'm plotting age here instead of score because it makes a nicer looking plot. I just chose to do that. So maybe I'm doing this because I'm interested in seeing if my sample was biased and I got older or younger participants in some of these racial groups. And it appears that I did. It appears that most of my Black participants are young, and that might be a caveat for me when I'm interpreting the results. Anyway, 50% of the Asian participants fall below 32, 50% of the Black participants fall below 24 in their age, and 50% of the white participants are younger than 36. So the bold line is the median. The gray box represents the 25th percentile and 75th percentile, so the middle half of the data. 25% of the Asian participants are younger than 22 or whatever, and 75% of them are younger than 41. And then the whiskers, that's what they're called, extending out from the top and bottom of the box, those identify the location of the minimum and the maximum. So our oldest Asian participant is exactly 50 years old, but our oldest Black participant is only 36. It looks like 35 maybe. I can't quite see where that would fall, but that's the nature of interpreting graphs. The point is to make them visually intuitive without being quite as precise as if I had the numbers printed on the screen. So this is already pretty nice for answering my question. Like if I was really trying to analyze, it's fake data, but if I really cared about these scores and I wanted to see if these racial groups differed on whatever this score is that I'm asking them, maybe it's an attitude towards some social policy or something, I should be pretty careful about comparing these groups in this case, because they don't just differ in race, they also differ in age. Clearly the Black participants are younger, possibly because I had a biased sampling strategy. If this was real data, that's the kind of thinking that I would start doing when I saw a box plot like this. But I can add to this box plot. I just want to show you how to add one more type of plot element. And again, I'm going to prepare that element ahead of time, like I did with the plotting colors up here. But this time I'm creating a new variable called means to plot. I've labeled these variables with very clear names for this example. Because I want to plot means too. You'll notice that box plot doesn't tell you anything about the mean of the sample, only the median. And so I'm going to show you one more new function, well, 2 more, tapply and points, but one more right now, tapply. And the grad students in the group might be thinking, why are you showing them tapply? That's a complicated function. And it is sometimes, but it's possible to use it in a very straightforward way. So I'm just showing you a very simple application of tapply right now. And that is a function where you just want to calculate some statistic for each of several groups. And all you have to do is specify what the numbers are, what the groups are, and then the statistic you want to calculate. And that's it. It will then, I'll show you what that does. It gives me a vector of 3 numbers corresponding to the mean age within each of these 3 groups. The first argument was that $age. tapply does not have a data argument the way plot does. So I'm using the $ in order to get the age vector from the data set known as dat. $age just gives me the whole vector of ages. And $race gives me the whole vector of races. Mean is already, we know about it. It's the name of a function that calculates the mean. I can calculate the mean of 1, 2, 3, and it will tell me that that mean is 2. So far I haven't explained this last argument, but these other 3, it just says, I want to do something with ages. I want to do it separately for each race. And the thing I want to do is compute the mean. And that's how I got these 3 means. The last argument, if you're going to copy this code and use it later, which I encourage you to do, that's like how people learn how to use R, is they get more and more examples, save them on their computer somewhere, and go back and look at them later and copy and paste lines of code to recycle. Most people aren't memorizing this stuff. So if you copy this for later and you're doing it with real data, you're probably going to want this argument too. All this does is it tells tapply to tell mean to remove missing values before calculating the mean. In this data set, there's no missing values. Everyone answered all 4 questions. But if a participant skipped one of them, like maybe this participant didn't have a score, I would want to remove them from the data before calculating the mean, because I can't use them in a mean. I don't know what their score is. So you'll notice if you're analyzing real data, it's messy, people skip questions on surveys, and you just have to be ready to take that into account. And usually that just means getting rid of those participants who skipped questions. This is a quick way of doing that. So all this together gives me means to plot, which is 3 means. So here's my box plot again. And I created an object called means to plot. And now I'm going to show you one last function, which is called points. Up here, ABline added a line to a graph. Legend added a legend to a graph. Points adds points to a graph that already exists. And in this case, it's a box plot. So I'm going to plot points based on their coordinates, but you might ask, wait, the x-axis doesn't have coordinates, it's just categories. It does have coordinates, they're just hidden from you. So this is 1, 2, and 3. It just calls these points along the x-axis 1, 2, and 3 for convenience later on. And because I happen to know that, I can plot points at those locations. Remember, the colon just tells me I can do 1:10 and it will count from 1 to 10. 1:3 will count from 1 to 3. So the first argument to plots is the x coordinates of the point. Sorry, the first argument to points is the x coordinates of the points I want to plot. And those are 1, 2, and 3. The second argument is the y coordinates. And those are those 3 means I calculated. And then PCH you should recognize, that just tells it to plot circles that are filled in, and you can experiment with all the different numbers to see what symbols they plot, triangles and diamonds and stuff. And the color is going to be purple. I just decided that. CEX is the magnification. 1 is the default. So I just want to make them bigger by making it 2 instead of 1. This is my way of telling R, plot some circles from 1 to 3 at the heights of those means, make them filled in circles, make them purple, and make them big. And now they're there. And so now I have a box plot and I have the means, and I can see some, things happening here. Like the mean age for the Black participants is quite a bit higher than their median, and that's probably because most of the Black participants are young, but there's a few outliers who are in their 30s that are bringing the mean up. But still, this sample of Black participants is clearly much younger than the samples of white and Asian participants here, suggesting that these sampling strategy conflated race and age and could create problems for generalizability. Well, if you are curious to learn more about this kind of thing, you can always ask me, of course, but you can also always visit my stats page on my website here. And these workshop videos are from a workshop I did in 2020. If you scroll all the way to the bottom of this list of videos, there's also a YouTube playlist. If you like that format, you can get to them on YouTube. But anyway, session 8, these videos down here give lots of examples of even more fun and colorful plots than the ones that I showed today. So if you want to get into some more advanced but not that advanced plotting, check these things out.